Good morning, everyone. Welcome to inspection and quality control video class. So we'll be covering with the fourth module contents of inspection and quality control. So in the fourth module of inspection and quality control, so the contents which you are supposed to discuss is acceptance sampling and reliability. So in the acceptance sampling, you'll be seeing what acceptance sampling is. So here single and multiple sample plans are discussed, construction and use of characteristics and simple problem. So further, what is reliability engineering, what is the practical activity, how to give a quality report building, what is reliability functions, all those things are discussed in the first part. So in the second part, you'll be dealing with what is MTBF, mean time between failure, and mean time to failure, mortality curve, useful availability, maintainability, system effectiveness, and simple numerical problems and reliability are discussed. So what is acceptance sampling is? Acceptance sampling is concerned with the decision to accept a mass of manufactured items as conforming to standards of quality or to reject the mass as non-conforming to quality. So the decision is reached through sampling. So acceptance sampling uses statistical sampling to determine whether to accept or reject the lot. Production lot of material. It has been a common quality control technique used in industry and particularly the military for contracts and procurement. So most often a producer supplies a consumer a number of items and decision to accept or reject the lot is made by determining the number of defective items in a sample from the lot. So lot is accepted by the number of defects falls below where acceptance number or otherwise the lot is rejected. So the purpose of acceptance sampling is inspection is carried out at many stages in the process of manufacturing. These stages may be inspection of incoming materials and parts, process inspection at various points in the manufacturing operations, final inspection by a manufacturer of his own products, and finally inspection of the finished product by the purchaser. So here acceptance sampling is here a lot is taken. So for that inspection is carried out. So that lot what all you test it is meeting the quality or not, that it is done by the quality control person to decide whether the lot has to be accepted or rejected. So inspection for acceptance is generally carried out on sampling basis. So here the use of sampling inspection to decide whether or not to accept the lot is known as acceptance sampling. A sample from the inspection lot is inspected. The number of defect item is more than the stated number known as acceptance number. The whole lot is rejected. So here the purpose of acceptance sampling is a method used to make a decision as to whether to accept or reject a lots based on inspection of samples. So here incoming inspection will be done, accepted lot, outgoing quality will be done. So here reject a lot subject to 7% inspection. So here what are the lot they take, they're going to check thoroughly all the components. Based on that the lot may be accepted or rejected. So acceptance sampling, it is a process of randomly inspecting a sample of goods and deciding whether to accept the entire lot based on the result. Acceptance sampling determines whether a batch of goods should be accepted or rejected. So here acceptance sampling is a very wide procedure in practice due to following merits. Acceptance sampling is much less expensive than 100% inspection. It is in general that 100% inspection removes only 80 to 82 to 95% of defective materials. Very good 100% inspection may remove almost 99% of defective, but still cannot reach the level of 100%. The effect of inspection fatigue involves 100% inspection. A good sampling plan will give better results than that achieved by 100% inspections. So here acceptance sampling is therefore a method used to make a decision whether to accept or reject the lots based on the inspection or sampling. The objective is not to control or estimate the quality of lot, but only to pass judgments on the lot. Operating characteristic curve. Operating characteristic curve shows the probability that you will accept lots with various level of quality. It is the working plan of acceptance sampling. That is, acceptance quality level is the maximum percent defective that can be considered satisfactory as a process average for sampling inspection. Rejectable quality level is percent defective. It is also known as lot tolerance percent defective. Lot tolerance percent defective of a sampling plan is the level of quality routinely rejected by the sampling plan. So in the operating characteristic curves, here it indicates how the lot is. Here you can see lot percent defective versus probability of acceptance. In the operating characteristic curve, you see the sample size is 98, acceptance number is only 4. So here with the AQL and RQL, AQL is acceptance quality level, RQL is rejectable quality level. So like this you can see the lot percent defective is. So like this, based on the acceptance sampling, here you can see what is the producer's risk and the consumer risks. Producer's risk is, if we have a good quality, the sample may show defective units such as a lot will be rejected. Such type of risk is known as producer's risk. Consumer risk, sometimes a lot is not good but sample results show good quality units such as consumer has to accept a defective lot. Such a risk is known as consumer risk. So like this, both the way the producer has also got risk and the consumer has also got the risk.